Derive Poisson's probability distribution as a limiting case of a binomial probability distribution solution if the number of trials n of a binomial distribution becomes infinitely large and p is the probability of success becomes very small. The binomial distribution tends to Poisson distribution. Let the binomial variate with the parameter n and p. So probability pxr is equal to ncr p raised to power r q raised to n minus r. R is equal to 0, 1, 2, so on, n, where p plus q is equal to 1. Now probability pxr equal to n factorial upon r factorial into n minus r factorial, ncr's value, p raised to power r, q raised to n minus r. Now is equal to n into n minus 1 into n minus 2, so on, n minus r plus 1 into r minus n minus r factorial upon r factorial into n minus r factorial, p raised to r, q raised to power n minus r. N minus r factorial to n minus r factorial cancel out, is equal to n into n minus 1 into n minus 2 and so on, n minus r plus 1 upon r factorial into p raised to r, q raised to n minus r, equal to n into n minus 1 bracket starts n minus 2, so on, bracket starts n minus r plus 1 bracket close, so p raised to r in place of q1 minus p bracket close raised to power n minus r upon r factorial, where r is equal to 1, 2, so on, and n because q is equal to 1 minus p. Let n tends to infinity and p tends to 0 in 1. And assuming that np is equal to mc, so which implies p is equal to m upon n, we get pxr is equal to n factorial n raised to power r into 1 bracket starts 1 minus 1 upon n bracket close, bracket starts 1 minus 2 raised to power n bracket close, so on, bracket starts 1 minus r plus 1 upon n bracket close upon r factorial, bracket starts m upon n bracket close whole raised to r, bracket starts 1 minus m upon n bracket close whole raised to power n minus r, or p x r is equal to one into bracket starts 1 minus 1 upon n bracket close, bracket starts 1 minus 2 upon n bracket close, so on, 1 minus r plus 1 upon bracket close upon r factorial into m into r, m raised to power r, bracket starts 1 minus m upon n bracket close raised to power n upon 1 minus m upon n bracket close raised to power r. This is equation 2. Since the limit n tends to infinity, 1 bracket starts 1 minus 1 upon n bracket starts 1 minus 2 upon n, so on, bracket starts 1 minus r plus 1 upon n bracket close is equal to 1. This is equation 3. And limit n tends to infinity, 1 minus 1 m upon n bracket close raised to power n is equal to e raised to power m, and the limit n tends to infinity, bracket starts 1 minus m upon n bracket close raised to power r is equal to 1, is equation 5. putting 3, 4 and 5 into, we get pxr is e raised to power minus m raised to power r upon r factorial. R is equal to 0, 1 and 2 and so on infinity, which is the Poisson distribution. Hence if n tends to infinity, p tends to 0, the binomial distribution leads to the Poisson distribution.